Hi, future doctors. Welcome to the next class. In this class, we will discuss about moment of inertia. Already we have given product of mass and square of the distance between mass particle and the axis of rotation. So, if any object you are going to take, it is rotating about this axis. So many mass particles will be there, m1, m2, M3. M3 is at a distance R3, M2 is at a distance R2, R1, and so on. So many will be there. So in this, how we will define moment of inertia means M1 R1 square. It is rotating in the circular path of radius R1. This is R2, this is R3. M1 R1 square plus M2 R2 square plus and so on Mn Rn square. So this one only they are going to write summation I is equal to 1 to n mi Ri square. So always axis of rotation may be no need to be within the object. Sometimes axis of rotation will be like this. Object may be rotating around this like this, isn't it? This is the axis of rotation if object is rotating like this. At the time, they will define radius of gyration or giration. It is denoted by k. So how they are going to define means the distance between axis of rotation and the center of mass of the object. The distance between axis of rotation and where total mass of the object is supposed to be concentrated, that is going to be center of mass. This distance we will call radius of gyration or giration. So how they are going to define means I is equal to m k square. K square is equal to I by m. K is equal to root I by m. So again, I can be written as moment of inertia of all the particles summation I is equal to 1 to n mi Ri square by capital M. This is nothing but radius of gyration definition. Units for this kg meter square. Dimension formula m l square. Units for this radius of gyration is nothing but distance. Distance units meters. Therefore, dimension formula is going to be L. So, like this we can take. I think in previous video I have given about acceleration and angular acceleration. Acceleration dv by dt I wrote, later v dv by dx I wrote. In angular acceleration, where velocity is coming, velocity d omega by dt, but in this v d omega, in place of v we have to write omega, d omega by, I think I wrote dx, but that should be d theta, because displacement is nothing but angular displacement. Therefore, omega into d omega by d theta. Maybe I wrote dx there. Once you can cross check in previous video where I wrote alpha, but that should be d omega by d theta. Wherever displacement is coming, there you should get angular displacement. Wherever velocity is coming, angular velocity. Next, I will see some problems on this. Two mass particles separated by distance r. Then find the moment of inertia about an axis which is passing through its center perpendicular to its distance. What is the moment of inertia about this axis means? Now you should find what is the distance between this axis of rotation to mass part. That is going to be r by 2. This is r by 2. Therefore, total moment of inertia m into r by 2 whole square plus m into r by 2 whole square. That is going to be mr square by 4 2 times. So, finally, you are going to get mr square by 2. Correct? 2 times of mr square by 4. Now, same question they are going to ask like this. Two mass particles separated by distance r. So what is the moment of inertia about this axis? So then I is equal to this mass particle is there on axis of rotation. Therefore r is 0. Therefore moment of inertia about this mass is 0. For this m is at a distance r. Therefore m r square. Next, if three mass particles given like this at three corners of an equilateral triangle, three mass particles A, B, C on an equilateral triangle A. So, find the moment of inertia about any axis they are going to give. We will see one by one according to the given axis. So, axis passing through AC. This is going to be AC. So, what is the moment of inertia about this axis they may ask. So, now on the axis of rotation, how many mass particles are there means 2. Therefore, these two will become 0. Now, this mass particle is at a distance. What is this distance? We should come to know. So, what is this distance means? This is going to be a by 2a. Maybe you will get root 3 by 2. Yeah, so many times we did. Therefore, I is equal to m into root 3 by 2 a whole square. That is going to be 3 by 4 m a square. Understood? Next, same question. Three mass particles they arranged on an equilateral triangle A, B, C. Three mass particles they arranged. So, what is the moment of inertia about this axis? So, about this axis means this distance is going to be a by 2. This distance is going to be a by 2. And this mass is there on axis of rotation. Therefore, you don't need to worry about C. Therefore, I is equal to m into a by 2 whole square plus m into a by 2 whole square. 2 times of m a square by 4. That is going to be m a square by 2. Correct? Next, same question. So, this is the triangle. So, three mass particles they placed at three corners A, B, C on an equilateral triangle of each side. So, what is the moment of inertia about this axis? They will ask at the time. So, this mass is there on axis of rotation, therefore, you don't need to worry. Now, what is the distance of this mass particle? Of this mass particle perpendicular distance. How much this is means? This is going to be this distance. So, what is this distance means? Root 3 by 2 a. So, in so many ways we can calculate. This is a. This is going to be equilateral triangle means 60 degrees. If you resolve, this is L cos 60. This is L sin 60 or A sin 60. A sin 60. Sin 60 value root 3 by 2 a. Correct? So, in so many ways you can calculate. So, moment of inertia equal to Ia plus Ic. A is at a distance root 3 by 2a whole square. So, this C is at a distance root 3 by 2a whole square. This is also root 3 by 2a. So, therefore, 2 times of m into root 3a by 2 means 3 by 4 a square. So, this 2 will be cancelled 2 times. So, 3 by 2 m a square. Just you can see how we are going to do the problems just by taking applying equation. Next, same triangle. So, they may give anywhere axis. From there, simply we are calculating what is the perpendicular distance A, B, C. The three mass particles, now axis is passing through its center perpendicular to its plane. So, that is what dotted line I am giving. So, this is the axis of rotation now. This is the axis of rotation. So, these three mass particles are rotating like this in a triangle. So, whenever these are rotating like this, then how the axis of rotation means? This is at a distance from this axis. So this is at a distance r. This is at a distance r. This is at a distance r. So this r we should calculate. So already we did so many times. If it is a, now what is r? A by root 3. So many times we have done this one. Who are following our videos, they will be coming to know, but already according to maths also you may came to know if you didn't follow also. Now I is equal to m r square plus m r square plus m r square. So 3m r square. So 3m, what is r we gave? A by root 3 whole square. So finally, how much you got? 3ma square by 3. That is going to be m a square. Next, another triangle I am giving. So three mass particles ABC. Now this is the axis. Axis is going to be, so these mass particles are rotating like this. This is the axis, means this is rotating like this. Those two remaining mass particles. Now, see the distance. This mass particle is at a distance a. Now this is at a distance. What is this distance? We should calculate. That is only going to be a by 2. Correct? So half of this one. Otherwise, you can do, this is 60. A cos 60, a sin 60. So a cos 60 is nothing but a by 2. So therefore, this mass particle is at a distance a by 2, m a by 2 whole square plus m. This is at a distance from this axis a. So m a square. So therefore, ma square by 4 plus ma square. So ma square common means 1 plus 1 by 4, 5 by 4 m a square. So that is nothing but moment of inertia. So today we discussed about this triangle model. Next we can take square like this. Just if you practice like this, you will get square also very easily. Mass particle and from axis of rotation, what is the distance, and just we are applying this formula.